We have already learned that Newton's first law of motion says that objects at rest stay at rest. Objects in motion stay in motion unless acted on by an unbalanced force which makes them accelerate. In other words, an object will not change state of motion unless an unbalanced force acts on it. All objects with mass have inertia. The larger the mass, the more inertia there is. That means the more it resists a change in its motion. So an object that is not moving, like this rocket, will not accelerate until an unbalanced force, like the engine, acts on it. I do not accelerate until an unbalanced force acts on me. Once an object is in motion, it will continue at a constant velocity until an unbalanced force acts on it. Unbalanced forces are needed to change an object's motion. Newton's second law describes the relationship between the mass of an object, the net force acting on the object, and the acceleration of that object. In other words, we can figure out the acceleration of an object if we know the mass of the object and the net force applied to it. To determine the relationship, keep the force constant, increase the mass, and observe the acceleration. In other words, we can apply the same force on different masses, but keep all other variables constant and observe the accelerations of the objects. We can then keep the mass constant, increase the force, and observe the acceleration. In other words, apply different forces on the same mass and keep all other variables constant and observe the accelerations. Remember, we're concerned with the net force. That's all the forces, all applied forces and friction. We are going to use a simulation to explore this relationship further.
The fan cart gizmo will allow us to find the relationship between force, mass, and acceleration. There are fans that can be used to apply a force to the cart to move it along a track that has no friction or air resistance. You can add masses to the cart to make it heavier, and fans can be placed on the cart to increase the applied force. After turning the fans on, you can change the direction of the fan. We want them facing forwards to push the cart down the track. After hitting play, you will see the cart move down the track until it hits the wall. The graph shown is distance versus time. You can copy it by clicking the camera and pasting it into your document. You will also need the velocity and acceleration versus time graphs for your document. You're going to use this gizmo simulation to determine what effect mass has on the motion of an object. This gizmo can also be used to determine what effect the applied force, which is the number of fans, has on the motion of the object. There are also other things you can test if you are creative.